Okay. Hello, I'm Coach Dalton. I'm going through a few problems of an SAT section over here. It's a no calculator section from the March 2022 test. So this is not the digital SAT, but I figure, we just got a couple months left of the paper SAT. I have all this amazing expertise and experience teaching this test for so many years that I figured I'd celebrate it by, sharing with you all that I know over the next couple months, I think, as long as they're giving this version of the tests. So I just figured we'd start with in the middle of the no calculator, not even the middle, kind of toward the end of the multiple choice here. So number 10, once again, this is the March 2022 SAT. Which expression is equivalent to y to the 1/8 times y to the 3/4 to the 3/2? So let's see here. Y to the 1/8 times y to the 3/4 to the 3/2. That looks okay, right? Looks fine. Did I write it right? Okay. Well, the first thing I want to do here is think about PEMDAS, right? We want to take care of the exponents and the parentheses stuff over here. And anything with exponents is just testing our knowledge of the classic exponent rules. I mean, I see in the answer choices there's roots going on here, so we're gonna have to deal with those at some point. But just when do you multiply exponents? When do you add them? Whatever. So let's see that y to the 1/8 I'm leaving outside here for now. But the y to the 3/4 to the 3/2, we just gotta multiply those exponents. Okay? Multiply fractions, pretty straightforward. 3/4 times 3/2, just multiply them across, right? 3/4 times 3/2, numerator times numerator, denominator times denominator. 3 times 3 is 9, 4 times 9 is 8. So now we have y to the 1/8 times y to the 9/8. Oh, well, that is very convenient. I like to see that because when we have two separate exponential terms like this, so we multiply exponents up here when we have one base with a couple exponents stacked on top, right? Like the base y to the 3/4, then parentheses, to the 3/2. A single base of y and then two exponents stacked on top. That's when we multiply exponents. But now we're in this situation where we have two separate bases, y and y. Of course, they have to be the same base, of course, right? But y and y, two separate bases. So here we're going to add the exponents. And this is why I said that was so convenient, because 1/8 plus 9/8, well, they're fractions and we need them to have common denominators to add them. And these are common denominators, I'm so happy to say. 1/8 plus 9/8, that's 10/8. Okay, now 10/8 is a fraction that can be reduced. So y to the 10/8, that's going to be like saying y to the 5/4. And now we come to the part of the problem we have to face what the answer choices look like, right? Look at these choices. There's no fraction exponents here. It's all roots. So we just got to remember how to translate between fraction exponents and roots. The denominator of the fraction exponent, the 4, is going to be telling you what kind of a root it is. And the numerator, the 5, just tells you that it's an exponent. So since we have there a denominator of 4, that's going to be, oh, my face is covering that. I'll just do it up here. 4th root of y to the 5. So what is that? Choice A over there, right? A is our answer. Okay. Let's take a look next at number 11. I don't really want to do this one. This is kind of like It's basically just knowing the unit circle. They barely even ask these kinds of questions. In fact, if I'm not mistaken, this is like one of the only times I've ever even seen them ask a question that really needed the unit circle. On this test, the paper SAT, all the trig stuff that you need is basically SOHCAHTOA, and then there's that complementary angle identity that they care about, right? Like the sine x is cosine of 90 minus x. Well, okay. But when you know the unit circle, you would know that any angle over 4 like this, a pi over 4 angle, that's always going to be root 2 over 2 or negative root 2 over 2. So right away, we know it's either going to be A or C. And now we got to know which quadrant this is in, because depending on which quadrant it's in, it's going to be positive or negative. If you know the unit circle, you know that this is in the second quadrant where sine is positive. So the answer is C. Again, I know that's not very satisfying. Believe me, it's not very satisfying for me to talk about it. But just know the unit circle. This isn't a video at the unit circle over here. Maybe I'll do that at some point. Okay, now this is a good question to talk about over here. This is like one of my favorite kinds of math questions that they have. I find them especially satisfying because they really make it seem like we need to have a good understanding of how this kind of weird equation works. But all we do, okay, whenever there's graphs and equations and our job is to match them together, maybe they'll put an equation in the question and then graphs in the answer choices, like they do here. More often, it'll be the other way around, where they'll have a graph in the question and then they'll say which of these equations in the answer choices match up with the graph. But whatever. Either way, if that's our job to match up equations and graphs, all you gotta do is plug in some points. So what's the easiest x value ever to plug into an equation? It's 0. So let's first write our equation up here. Y equals 2 to the negative x plus 1. That's our equation, right? Yeah. So let's plug in x equals 0, okay? So now it's going to be y equals 2 to the 0 plus 1. Negative 0 is 0. You know that, right? Anything to the 0 is 1. You know that, right? 1 plus 1. So that's going to be 2. So what we just learned is when x is 0, y is 2. That's what we just learned. So now we look at our answer choices and see which of these graphs has that situation. I see choice A does, 0, 2 is right there. Choice B does not, so we cross that out. Choice C does, so we leave that in. Choice D also does. Oh, dang. Well, that wasn't super effective. It did get rid of B, though, at least. I'm happy about that. So now all we'll do is we'll do it again. So I'm just going to rewrite the equation again. Y to the 2 to the negative x plus 1. Okay. And now, ordinarily, I would plug in x equals 1 next. But I think for this particular equation, since negative x is the exponent, I'm going to plug in negative 1. But 1 would work too. This is just going to make it easier for me because I'm going to get rid of the negative stuff this way because negative 1 is going to be positive 1. So now we say y equals 2 to the negative 1 plus 1. Negative 1 is just positive 1, right? That's how that works. So 2 to the 1 plus 1 equals 2 plus 1 equals 3. So we just learned that when x is negative 1, y is 3. That's what we learned. And now how many answer choices say that? Choice A, negative 1, 1, 2. Look at that point right there. B, we already crossed out. C, negative 1 is not at 3. D, negative 1, 1, 2, not at 3 either. So once again, A is our answer over here for number 12. Nice, right? Isn't that just so great? Okay. Oh, this one is fun. In 2005, 10 phlox plants were planted in a garden. The number of phlox plants increased by 140% each year. Which of the following equations best models the estimated number of plants P in the garden T years after 2005? Okay, look. Let's just keep it very simple over here. Let's just talk about percent change real quick, okay? This is the big mix-up that everyone has with percentages. So if you want to take 20% of X, right? If that's your goal, 20% of X, well, you're going to multiply X by 0.2, aren't you? Because that's what 20% is. But if you want to increase X by 20%, well, you're going to multiply X by 1 plus 0.2. We take that same decimal value of the percentage, 0.2, we add it to 1. 1 plus 0.2 times X. So it's going to be 1.2X. Okay, so to take a percentage, you multiply by that decimal form. To increase by a percentage, you multiply by 1 plus that decimal form. Okay? Now, that might sound obvious to some of you, but this is number 13. So we need to respect these late questions. Remember, in the no calculator section, it only goes up to 15 in the multiple choice. So there's 15 multiple choice questions. Then you have those grid-ins, 16 to 20. And the difficulty resets back to easy mode for number 16. So number 13 is a late question. So let's respect that. There must be some easy mistake to make over here. So we want to increase by 140%, right? So that's our goal. So the first step is, what is the decimal version of 140%? There's different ways to do this. You can imagine just moving the decimal point 2 spaces to the left. You can imagine dividing by 100. You can just know that it's going to be 1.4, right? That's the decimal. So what do we do next? Oh yeah, we're trying to increase by 140%. If we wanted to just take 140%, we would just multiply by 1.4. But if we're trying to increase by 140%, we're going to add 1 plus 1.4. And that gets us 2.4. So that's what we're going to be multiplying. Now, how many answer choices contain 2.4? 2 of them. B and D both have 2.4. And this is where just our knowledge of how these exponential change equations work comes into play. The change information, usually these are percent change, these questions, but even if it's not, like the information where you get that tells you about how to change the number, that goes inside the parentheses. So the answer is going to be D. The number before the parentheses is the starting value. So that's why 10, we're counting in 2005, that's why 10 goes before the parentheses. So our answer is D over here. Now, I realize this might seem a little easy. I don't know, does it? I don't know. But what I think it's surprising to some people that 2.4 is the answer, or 2.4 is a part of the answer in a question that involves 140%. You might think that 2 would be for a 200% thing or whatever. But keep in mind, when you increase something by 100%, you double it, right? When you increase something by 100%, you're doubling it. So to represent increasing by 100%, you would multiply by 2. So not as wild as you might think. Okay, let's move on. Number 14. The complete graph of the function f is shown in the xy plane. What is the y-intercept of the graph of y equals f of x plus 2? Okay, well, first of all, do you see a trap answer here? Here's the truth. You may not get every single question right in the math section. You just may not, okay? I'm sorry. But you can be pretty strategic in the way you guess on this test by being aware of where you are in the section. So once again, we're pretty late in the section now, right? This is number 14. So that means that the answer is not going to be pretty easy to get. Look at this graph. Look at what they're asking for here, right? The y-intercept. Does one of these answers seem just suspiciously easy? Yeah, choice B. That is the y-intercept of this graph. There is no way that a number 14 on this test, remember it only goes up to 15, the multiple choice, they're going to just be asking you to look at a graph and say, what's the y-intercept? Maybe if this were number 2, that'd be fine. But number 14, no. So, yeah. So I would just say cross out B. And then guess from the remaining ones. If you had no idea how to do this. I just want to put that idea out there that just because you don't know how to do a question doesn't mean like all is lost and it's time to just guess randomly. You can often look at the answer choices and identify at least one trap answer because it's an answer that would be too easy to get. Okay, I'll talk about that later maybe. Okay, so this is basically a graph translation question. If we're adding or subtracting a number inside the parentheses like that, that means we move the graph from right to left to right, whatever, side to side. If they had put the plus 2 on the outside, like if it had been like this, if they had said this, f of x plus 2, like that, outside the parentheses means moving up and down. But that's not what they did, is it? They said right to left. Now, when you move things side to side like this, it's the opposite of what you might think. So the fact that it's plus 2 inside means that we're going to be moving this line, this curve, this graph, whatever, to the left 2 spaces. So just look at that. Imagine moving that to the left 2 spaces. This point would be now over here, and then it would be over here. This point would be boom, boom. So where would the new y-intercept be? It would be 1 up from the old y-intercept, it looks like. So 0, 3. So choice A is what the answer is to that one. Okay. I think that's about all I have to say about this one. Yeah. Let's just do the last one, number 15. Oh, this is kind of an interesting one. One of the two, let me erase this. One of the 2 equations in a linear system is 2x plus 2y equals 2. The system has no solution. Which equation could be the other equation in the system? Okay, before we even talk about what it means to have no solutions, I want to just point something out about this equation they give us. 2x plus 2y equals 2. Do Does this make you want to do something when you look at this equation? Does anything come to mind? I mean, if it's me, I would say, yeah, there's a 2 everywhere. So we just divide the whole thing by 2, both sides of the equation by 2, and we get x plus y equals 1. That's like the real equation. Whenever they give me any equation on this test, I always like to ask myself, is there any way I can make this equation a little prettier, a little easier to work with? Can I multiply both sides by something to get rid of the fractions? Can I divide both sides by something, like here, to make the numbers smaller? Let's make things easier on ourselves, okay? So anyways, that's the real equation that we're working with now. So they want to know if the system, they tell us the system has no solution. You know what that means? Well, think of it this way. What does the solution of a system of equations usually represent? It represents intersection points. So, if we have a linear system of equations, where we have 2 lines, of course, where the lines cross, that's going to be the solution to the system. But if it has no solution, what does that mean? It means we have no intersection points. Okay? No solution means no intersection. And what kind of lines have no intersection points? Parallel lines. Okay. And what's like one of the main things we know about parallel lines, aside from the fact that they have no intersection point? I just wrote that. Yeah, it's that they have the same slope. Okay. So I'm going to rewrite the equation up here. X plus y equals 1. Remember, that's our equation now. So basically, we are looking for an equation that has the same slope. Now, before we get into how to do that, I'm just looking at the answer choices again here. Does one of these answer choices jump out at you as something that we could do something with? Maybe something we've already done in this question? Yeah, choice B, right? Look at that. 3x plus 3y equals 3. That's also an equation we could simplify, isn't it? We could divide both sides by 3, and then what would that become? It'd be the same equation over here, right? X plus y equals 1. Well, if it's the same equation, it's not going to be the one that makes no solutions. If we have 2 equations and they both turn out to be the same equation, that means we don't have 2 lines, we have 1 line. Like the 2 lines are just on top of each other. So instead of having no intersection points, they only have intersection points. If the lines are right on top of each other, they're just constantly intersecting. They have infinitely many intersection points. That's what it means to have infinitely many solutions. Okay? So B is not going to be the answer. So now let's get the slope. There's a couple ways we could get the slope with an equation like this. One of them would be we could rearrange the equation into that beautiful y equals mx plus b form. But I want to show you what I think is to be a more useful way to get it. It has to do with the situation we're in here when we have linear equations that are in what's called standard form, which is ax plus by equals c. When we're in this situation, the slope is going to be negative a over b. So for our equation here, looks like our A value is 1. Our B value is also 1. So our slope is negative 1 over 1. It's negative 1. So now the question becomes, which of these answer choices has a slope of negative 1? Choice B we already got rid of. Let's look at choice A. 3x minus 3y equals 3. Which actually we can divide both sides by 3 of that one and get x minus y equals 1. Okay. So what's the slope of this one? Well, negative a. Here our a is 1 and our b is negative 1. So our slope is negative 1 over negative 1. Slope is 1. That's not going to be it. We want to have a slope of negative 1. Okay. How about choice C? Look at choice C. X minus y. This could also become x minus y equals 1, couldn't it? All you do is divide both sides by 2. And we just tested that equation, so we're getting rid of C. And since we already got rid of B, I guess the answer is going to be D. Now I'm going to show you why D works, but I just want to be clear about this. When we're in the math section, if you get rid of 3 choices, you're done. You pick the remaining one and you move on with your life. If you're in the reading or writing sections, don't do that. You need to make sure that the last answer choice does make sense. But math, you can do that. Let's just take a look at this last answer choice here. 2x plus 2y equals 3. Now, here, this one we can't do any dividing or anything, whatever. So the slope here, negative a over b. Here our a is 2 and our b is 2. So negative a over b was going to be negative 2 over 2, which is negative 1, which is the slope we were looking for. So we can go ahead and pick D. But again, we don't need to really even do that. Because in the math section, you cross out 3 choices, you're done. Okay, I think that's enough for now. I'll see you next time.